Morning friends, myself Dr. M.H. Anaya, and in today's video we are going to work out a problem on the projection of a cube. Friends, a cube is also called as a hexahedron. Hexa means 6. It has got 6 faces. 1, 2, 3, 4 on the lateral surface and one at the bottom and one at the top. Totally 6 faces are there. And remember friends, all these faces are all squares and all the edges measure the same dimension. Friends, this cube can be considered as a square prism with reduced height, with height is equal to this side. Friends, in the question for today's video, it reads like this. A cube of side 50 mm rests on HP on one of its sides. Such that, okay, it is resting on HP on one of the sides. Friends, we are supposed to keep the cube on HP, which one of these side normal to VP, and obtain its top view, a square of 50 millimeter side, and front view, another square of 50 millimeter side. So friends, I will just mark XY line and then mark two squares, one for the top face and the other for the bottom face. So this is the top face and it has got a dimension 50 mm. I will call it as SQ50, means all the sides measure 50 millimeter each. And we'll number these as ABCD, ABCD. And in the front view, by projecting the lines, we will also draw another square having the same dimension, and I will show here only 50. That is the height of that. Again friends, remember this is 50, this is 50. Automatically it is a square of 50 mm side. Friends, this marking I have done A, B, C, D is for the top face. So I will call it as A dash, B dash, C dash and D dash. So A dash, B dash, C dash, D dash is the top face. And friends, similarly for the bottom face, we will mark it as 1, 2, 3 and 4. So friends, here on this you get 1 comma 2 and the bottom face this is 3 comma 4. Friends, particularly in case of cubes, you should be very careful, and I advise you all to have or to take what is called different naming for the bottom face and the top face, since they are very closer to each other. Now friends, you have placed the cube on HP and obtained the top view a square and the front view another square of the same side. It says it is resting on one of this, such that one of the square faces containing that side. So if I am just tilting this to the right, say like this friend, that one of these face, that is it was like this, I am going to rotate like that, so that one of the square face containing that edge on which it is resting is at an angle of 45 degrees to VP. So it's a 45 degree HP. Friends, I will just redraw this figure, this square. So this is at an angle of 45 degrees to the HP. So this face I have just tilted like this. Friends, I will complete this and obtain the view of this. So friends, this is rotated, tilted to the right side. This is 3 comma 4 and this is C dash D dash. This is A dash B dash and bottom face is 1 comma 2. Friends, I had this cube, I have rotated, so this is making an angle of 45 degree. Since this total angle is 90 here, friends, very obviously even this will be equal to 45 degree. So now the cube is resting on one of its sides, that is 3 4 on HP, such that the square face, that is 3 4 CD at this line, is making an angle of 45 degrees with the HP. Now friends, we will obtain the corresponding top view for this by drawing verticals through all these points. So friends, here you can just observe, that is by projecting these lines onto the xy, we will be able to obtain the corresponding top view of these. So friends, let us take the points one by one. Friends, this surface, I will show you practically. This surface is ABCD. This is seen and AB12 is also seen. So in the top view, you are going to have two square faces seen as rectangles. So it becomes a rectangular surface. Friends, let us take points one by one. Vertical from A, horizontal from A. This point will be our A. Vertical from B, horizontal from B will give you the point B here. This is A, this is B, and C and D fall on this. So you just project the lines, friends. This is the point C, and by extending this, you will get the point D. So I have just taken the projectors from the front view and to the top view. Friends, this again, 1.2 is here. Now we can, before that, let me complete this ABCD. Friends, this is the top view of the square face which has become a rectangle, that is ABCD. Similarly, friends, for the bottom, that is this side, AB1 to will mark, this is point 1 and this is point 2, 3 and 4 are here. I will just mark 3 here and this point is 4, A comma 4. Friends, all the border lines are to be shown by visible lines. They are all visible. And friends, if you see here, the side AB is visible here. The side on which it is resting is 3 4, that is covered by this, and I have given prominence to this edge which is visible in the top view. Friends, this is one rectangular face, this is one rectangular face that is seen in the top view, friends. Now what does he say, friends? Inclined 40, draw its projections when the side on HP is inclined at 30 degrees to VP. Friends, if you see the front view, the solid is resting on 3 4, the side 3 4. That the side 3 4, you can see here, is perpendicular to VP. I will say here, side 3 4 is perpendicular to VP. Friends, that has to be at an angle of how much? 30 degrees to VP. Friends, I have to reproduce this figure on a line which is inclined at an angle of 30 degrees to VP. So friends, here I will just mark this 3 4 on this, or anyway it can be marked. This is the thing I have marked again here, this rectangle, friends. So this 3 4 is at an angle of how much? We will just mark it. This is CD. If you keep like this becomes D. This is C, and after opposite to CD is 1 comma 2. 1 is here. This is 2. This point is 3. 1 2, and then AB. AD you get A4D. This is A4, A comma 4. This is D. On the other side, C B3, C B comma 3, and then you have this point 1. So friends, I have just reproduced this figure here, but here the side on which it is resting is 3 4. That was perpendicular, and have drawn that at an angle of how much? 30 degrees to VP. Say this is 30 degrees. And he has clearly mentioned only that side should be at an angle. So very obviously all these will be at the same angle because they are parallel to each other. Friends, this figure, whatever you have drawn here, is the final top view of the cube. And let's see how the front view looks. Friends, if you see here, the face ABCD, that is this face, is near to the observer and you will be able to see all these. So first of all, let us complete the projection of this in the front view. So I will start from point A. Friends, A and B should lie on this. So first of all, we will write a line here on which A and B should lie. Friends, A, like say, so draw a vertical line from a horizontal from A dash, the point where those two intersect is our final corner A dash. Similarly, friends, B is here, and now draw a vertical line from B, a horizontal from B dash. This will give you the edge at the corner B dash. So we got A dash, B dash. Then friends, on this you get C and D. So I will write a horizontal line through this and we have to mark C and D. So draw a vertical line from here, from this D, a horizontal line from here. This is going to be your point D. Similarly, C, horizontal line from C, if drawn and vertical line from C, they meet at some common point. So I will call this as point A, B, C and D. Friends, I told you the face ABCD of the cube is nearer to the observer and hence all this is totally visible and you have to show by what we call visible lines or dark line. So friends, we have got one of the faces of the cube. Friends, we follow the same procedure and obtain the other 4 points, namely 1, 2, 3 and 4. Friends, let us start from point 1. 1 is here, a horizontal line from 1 dash, a vertical line from 1 will meet somewhere here and we will call this point as 1 dash or simply 1 or 1 dash. This is 1 dash. Similarly, friend 2 will also have on the same line point 2. So this is going to be point 2. 1, 2 we have got. Then we have got 3 and 4 on xy. So 3 is here and the point 4 is here. Somewhere here, friends. Yeah, this is going to be point 4. Friends, now let us join 1, 2, 3 and 4. So before that, let me mark only the borders of the figure to start with. That is to say, this is the border line B to 1, then friends, no, this is B dash to 2, it should be B to 2. So this is C3 and D4. Friends, I am going to join like this. The borders are visible. So this has to be joined like this. This has to be joined here and this C3 then D4 all are joined here, friends, and this is the top face, the other face. This is 1, 2, 3, 4 I have marked, 3 and 4 are here. Friends, if you just join this and you observe here, friends, the square faces appear as rectangles there. And what is not visible here, friend, is the point 1. And this point is not visible in the front view. So, friends, this A to 1 is to be shown by a dotted line. Similarly, this edge is not visible. Since this is not visible, all the connecting lines are also not visible. And hence I show them by the dotted lines. Friends, finally, this will give you the front view of the cube. This is the top view of the cube, and this satisfies all the requirements put forth in the question. That is, let us check whether the solution we have got is right or wrong. Friends, we have the cube resting on one of the side, and the two triangles containing that, or the two square faces, are equally inclined. You can observe here, friends, if you observe closely, this face, that is CD43, and this 3412, these two are equally inclined to HP. They make 45 degrees with the HP, which is very obvious from this figure. Friends, please go through the complete video, and if you like this video, do share with all your friends without fail, and have a blessed day. And I thank you very much for watching my YouTube video.